Welcome to solverfy.
Session, we have this setup. The slider block is moving to the right with a speed of 4 meters per second with an acceleration of 2 meters per second squared. And so we need to determine the angular velocity and angular acceleration of the wheel at this instant. Okay, so let's just write down what we have. So VB is 2I, 4I, and then AB is 2I. Okay, so we can calculate VA. So because VB is moving to the right, so we expect the wheel to rotate counterclockwise. Yeah, because if not, and because it makes sense if the wheel is rotating counterclockwise, and then the rod would turn counterclockwise, and that would make slider block B to the right. Okay, so VA, we expect it to be going downward. Okay, so it's going to be 0.15 omega negative J. Okay, and then the acceleration of point A will be alpha K it will have a tangential acceleration, assuming downward. Okay, yeah, and then the normal component of the acceleration will be omega squared times r, which is also 0.15. Okay, so in the I direction, so we have 0.15 omega square I minus alpha j, okay, for the acceleration of point A. Okay, so VB is equal to VA plus omega AB cross R B relative to A Okay, so that means we have 4I is equal to minus 0.15 omega J plus omega AB K cross. So the position of B relative to A, this is equal to 300I, 0.3I minus 0.4J. Okay. So let's continue. So doing the cross product, okay, we get 0.4I plus 0.3J. Okay, then we group the terms together. 0.4 omega AB I plus 0.3 omega AB minus 0.15 omega J. Okay, so from here, if you compare the components, okay, so the X component, we get omega AB is equal to 4 divided by 0.4, this is 10 radians per second. So from the Y component, okay, we have omega is equal to 0.3 divided by 0.15 omega AB. So we have 20 radians per second, okay, counterclockwise. Okay, so this is the angular velocity of the wheel. Okay, next we work on the acceleration. So for the acceleration, okay, so we have the we have the the acceleration at a to be 0.15 omega square I minus alpha j, right? So since we know alpha is 20, so we have 0.15 400 I minus alpha j. Okay, and then AB is equal to AA plus alpha AB cross RB relative to A minus omega AB square RB relative to A. Okay, AB is 2I. AA acceleration of point A is 0.15 times 400 I minus alpha J plus alpha AB K cross 0.3 I minus 0.4 J minus 100 0.3 I minus 0.4 J. Okay, so just continue. 60 I minus 0.15 alpha J plus alpha AB 0.4 I minus plus 0.3 J minus 30 I plus 40 J. Okay, group the terms. So we have 30 plus 0.4 alpha AB I plus 40. Okay, there's a negative 30. 40 minus 0.15 alpha plus 0.3 alpha AB J. Oh, yes, sorry. This is positive. Okay, yeah. 60 minus 30 gives 30. Okay, yeah, sorry. Okay, so comparing components. Okay, so for the x component, 2 is equal to 30 plus 0.4 alpha AB. So alpha AB is equal to negative 70 radians per second square. And then for the y component, we have 0.15 alpha is equal to 40 plus 0.3 alpha AB. Okay, so alpha, so you put 40 plus 0.3, 70 negative. Okay, so alpha is 19 divided by 0.15 is equal to 127 radians per second square. Okay, and then the direction is counterclockwise. Okay, so this is the direction. This is the answer. Okay, for the angular acceleration of the wheel, and that's all.